Hello friends, welcome to the first tutorial in the series of LABVIEW for engineers. In this tutorial we are basically going to walk through the software and learn some of the basics to get used to the LABVIEW programming environment. So to get started, let's open up the LABVIEW. It will take a while to load depending upon the system configuration, and once it's done, this is the very first window of LABVIEW that you will see. It gives a couple of options to open previously built VIs, create a project, or start working on a new VI, or we can say blank VI. Projects are important when we are working on big applications that require multiple sub-VIs. There it's important to organize these sub-VIs in a project hierarchy for easier compilation and building executable files of the VI as well. In our case, we will start with a blank VI, so navigate to File and select New VI. This is a peculiar two-window setup that you will be working in LABVIEW to build VIs. One is the front panel, which forms the user interface and consists of controls and indicators. And other window is the block diagram, which is the programming area. This is the programming area where we will use operators, structures, sub-VIs, functions to create the data flow. You may switch between these two windows by clicking Ctrl A. For now, we will tile these together so to have a better view and understanding of the workflow in LABVIEW programming. If you right click anywhere on the front panel, you will get the controls palette. It contains all the controls and indicators in different formats for different data types, whether it be numeric, boolean, or string. Similarly, if you right click anywhere on the block diagram, you will get the functions palette, which contains programming operators and functions to build a particular application. Let's go back to the front panel and choose numeric control. So right click, numeric, and we choose the numeric control, and we will place it anywhere on the front panel. As soon as I place this on the front panel, a corresponding terminal appears on the block diagram. Let's create an indicator as well. Numeric indicator. So for our purpose of studying, let's say this is numeric, let's rename it to numeric indicator, and let's say this control that we have placed is numeric control. For both the items in the front panel, now we are having the corresponding terminals in the block diagram. As we can notice in the block diagram, the difference in the control and the indicator is the placement of nodes. Numeric control are having nodes on the right hand side, while the indicator are having nodes on the left hand side. If you take your pointer to one of the nodes, you will see that the cursor changes to wire tool. These are the wires which create data flow in the block diagram. Alternatively, you can also choose the wire tool from View and selecting Tools palette. So here is the wire tool. So let's try to wire these two together. From the numeric control, we pull a wire towards a numeric indicator. So now let's change the option to automatic again and close the Tools palette. What we have actually done is we passes on the data from the input, which is numeric control in our case, to an output which is numeric indicator through this wire. Essentially, this may be your very first program where you are displaying the value of numeric control in the numeric indicator. Let's input value 5 to the numeric control and run the program by hitting the run button or Ctrl R key. So if we run the program, we will see the numeric indicator updates to value 5, which is what we have entered in the numeric control. So if we change the value here, let's say it's 10, run the program, we will see that the value updates to 10 in numeric indicator. This we can do with any type of data. Let's take an example of Boolean. We may choose a toggle switch to control the Boolean LED. So we select a Boolean toggle switch from here, and we will select a square LED as an indicator. We may resize them to fit our objective and user interface, and we try to connect these two with wires in the block diagram. Let's try to run the program in the continuous mode and see what happens if I toggle the switch. If I toggle the switch to the right, the Boolean glows up. What it means is we are passing true data from the Boolean control into the Boolean indicator, and if I turn the switch to the left side, the value returns to be false. Now let's try to create a program with operators. We will abort this program from here, abort execution button, and we will get rid of all the items in the front and the block diagrams. Let's say we want to sum up two numbers entered by the user. So we select two numeric control keys, numeric control one, which we say num A, and another one num B. So now we have the terminals for num A and num B in the block diagram, and we also want to display the result of the summation of num A and num B into a numeric indicator. Let's take a different type of indicator for now. Let's take maybe a gauge. Okay, so we have a gauge, which is our indicator, and the corresponding terminal for the gauge appears in the block diagram. Let's rename it to sum. Now we'll come to the block diagram and try to figure out how we can sum num A and num B. If you right click the block diagram, you will get the functions palette. From here, if you go to the numeric, you will find the function or the operator add. If you place it add here, you will find the add has two terminals to the left, and these two terminals will correspond to each of these controls. So what it is essentially doing, it is taking the addition operator, is taking values from num A and num B and outputting this value to a sum indicator. So let's try to run it. Let's say I want to find the sum of 5 and 2. Hit run. It's 7. So let's try two different other numbers. Let's say we want to find out the sum between 25 and 35. So let's run the program to find the sum, and the dial gauge shows it's 10. No, it's not 10. We have actually restricted the scales of the dial gauge from 0 to 10, so we have to correct it. So right click the dial gauge, go to the options, go to the scales, and in the maximum rating of the scale, enter 100. So as soon as you do that, you will see that the needle goes to 60. So now if I want to find out the summation of 35 or 36 and 35, then the dial gauge will show 71. Now let's say you want another operation to be followed, and you want to calculate an expression for the summed quantity. Let's say the expression is 2 minus log of x. Anyways, you can double click anywhere in the block diagram or the front panel to write the descriptions, which are important from the point of view of the user as well as the programmer. So we want to calculate this expression 2 minus log x. So we first try to put the logarithmic operator. So if you do not know where the logarithmic operator lies in the functions palette, you can search it in the functions palette. Go to the functions palette, go to the search and write log. So it gives you the relevant results, and you can choose from them. So I want logarithm to the base 10. So I double click it, and it goes to the place where the log 10 or the logarithmic function lies. So I can choose logarithmic function and place it on my block diagram. So now these wires are actually the data flows. What is in this wire is the summation of num A and num B. So I want the logarithm of this summation, so I will branch out a wire from here and connect it to the logarithm. So what lies in the other end of the logarithm is the log of the sum part, which is log x. So now other thing which I wanted in my expression is the subtraction. So I will go to the functions palette again, go to the numeric, choose subtract, place it near the logarithm part, and I want this logarithmic part gets subtracted from 2. So I will connect this here, and I will go to another node and create a constant. By default the constant value is set to 0, and in our case we have to replace it by 2. So the output here will be 2 minus logarithm of x. So we can display it. To create an indicator here, we just right click at the node, create, and create an indicator. So here is your x minus y. Just place it here. So if I run the program now, what I will find is the value of 2 minus log x, which is 0.148742. In another way to evaluate an expression, we can also use the expression node. So just go to the block diagram, right click, go to the numerics palette, and then choose expression node, and just write down whatever expression you want to evaluate. In our case it is 2 minus log of x, and in the same way we can branch out to connect our expression node and create an indicator in front of it. Create indicator, and I will say indicator and expression node. Just place it near to the x minus y. So if now I will run the program, I will get the same value in both of them, because both of them are evaluating the same quantity, just in a different way. So we can adopt to any way we like. If you are having a big expression, it is more easier to use an expression node. So now let's take another example where we will use different data types together. So first get rid of it. So we just select the program and hit delete. It will clear our front panel and the block diagram as well. Let's say we want to build an application to find if the number is odd or even. To start with, let's go to the front panel and create a numeric control, and we can say it is input number, and I want the results in the form of glowing of LEDs. If the answer is even, a green LED should glow, and if the answer is odd, a red LED should glow. So I put 2 LEDs corresponding to the even number and the odd number. So if the number is even, the green LED should glow, and if the number is odd, the odd LED should glow, but this odd LED should glow in the red color. So I want to change the color of the LED. I can do this by going to the properties of the odd LED and changing the on state color to red. Let's say okay. So whenever there is a true state in the odd LED, it will glow to red like this. So now coming back to the block diagram, let's see how we can program to find if the number is odd or even. One very simple way is to find the remainder when the number is divided by 2. If the remainder is 0, it's even. If it's not 0, then it's odd. So let's place a quotient and remainder operator from the numeric functions palette and divide this input number by 2. We could create a constant. In its case it will be 2, and we want to test the remainder. So we want to test or compare the remainder if it's equal to 0 or not. So from the comparison palette we can choose equal to 0 and wired it up. So what this equal to 0 operator is giving us is a Boolean output. If the remainder is equal to 0, it is the output is true. If the remainder is not equal to 0, the output is false. So in case the output is true, that is the remainder is 0, the true will go to the even LED and it will glow up. But in case the output is false, if the output is false, obviously the even LED will not glow because the data in the wire is false, but we want that data to be true to glow the odd LED. So we can use this Boolean operator NOT to change the false state into the true state when the remainder is not 0. So here is our program, and let's try to run it. Let's say the number is 26. See which LED will glow. Yes, it's even. Now let's say the number is 31. Let's say which LED will glow. Now it's odd. So now let's try to decorate or make our UI or give our UI some rich look. So we can do that by increasing the size of the LEDs. You can just drag, and similarly, and I want this LED to be of same size, so I can select both and then select maximum width and height. Then I can place it in the equal towards the left. Fine. And I can place the hole in a recessed box. The recessed box is above, so I will choose the recessed box and send it to the back. And I can write here application to detect odd and even number. I can put it anywhere, inside, outside. I can give it a heading look by hitting Control 0. I am into the font style. I can select bold and increase the font size a bit, and that's it. In the same way, you can also describe your block diagram for your own reference and the reference to the end users. So let's say this is step 1, user input value. The step 2 was finding the remainder. So finding remainder. Step 3 was here. Step 2 was related to this part. Step 1 was related to this part, and step 3 was comparison, and based upon comparison, this part here is the decision. So I can just decorate it a little bit for my own understanding. I can say this part of the program was decision or indicator. So I can point this to this value. Sorry. These are very simple examples, yet very important for developing the concept of graphical programming in LABVIEW. I hope you have enjoyed the tutorial. Next we will take up about structures and arrays. So thank you.